Welcome to 8.4, Quadratic Functions and Their Graphs. This is a very important lecture. This lecture is a culmination, a synthesis of a lot of what you've learned in this class, put in all into one section, okay? You might call this the big climax lesson, the big finish, the big finale. And this is not the last lesson we're doing, but this is the last really important lesson we're doing. Okay, so first of all, what is a quadratic function? So I'm starting on page 713. A quadratic function is a function of the form f of x equals ax squared plus bx plus c. Of course, we've been studying functions for the whole semester, and we've seen polynomial functions ever since chapter 5. And you've dealt with quadratics starting in chapter 5 as well. You learned how to add them and subtract them. You learned how to factor them. You learned how to even use the quadratic formula in the last lesson. But now we're going to really focus on graphs. At the beginning of the semester, we focused on a very, very important graph, the graph of a line. I said in a couple lessons earlier, probably actually in a few lectures across the course of this semester, that there are two graphs that you need to master for this class. You need to master how to graph lines, and you need to master how to graph parabolas. And that's what we're looking at today. We're looking at how to graph parabolas. So quadratic functions, when graphed, are parabolas. Let's start with question 1 from the MyOpenMath homework. Here we are given the quadratic function f of x is equal to 2x squared plus 2. Now this type of graphing we're about to do is the simple graphing that comes from making an xy chart. We've already done this in this course. We've done this earlier on in the course. How do we graph functions? We make an xy chart. We figure out what the y values are that correspond with the x values by plugging those x values into the function. And then we make a graph. So there's nothing new about this, but I wanted to go ahead and start the lecture with reviewing this concept. So what we're going to do is we're going to replace x in the function with each of these values right here in turn. So when you plug in a negative 2 squared is 4, 4 times 2 is 8, plus 2 is 10. Plug in negative 1, you get 4. Plug in 0, you get 2. Plug in 1, you get 4. Plug in 2, and you get 10. So to graph this, on MyOpenMath, you only need to pick 2 points, and it will take a little practice. If you graph it incorrectly, remember that you can fix the graph. There is a button that says Clear All. Okay, so when you graph, first of all, you're going to need to select the parabola graph. Don't graph it as a line, and don't graph it as an exponential function. Select the parabola shape, and then you're going to need to graph the vertex and one other point. And here the vertex is the point that goes through the line of symmetry. In this case, the vertex is at 0, 2. I'm going to be plotting by hand, but when you graph this on MyOpenMath, you need to start with the vertex. The vertex is this point right here. How do you know this is the vertex? The vertex is the point of symmetry, okay? In this case, it's the lowest point on the graph, and you can see that to the right of 0, at 1 and 2, the number goes up to 4 and 10, and to the left of 0, going back to negative 1 and negative 2, the number goes up to 4 and 10 as well. You see the symmetry of these numbers? Then this right here is the vertex. So you graph the vertex first, and then you graph one other point. So if you graph one other point here, you could just graph 4. And on MyOpenMath, by graphing just these 2 points, it will be enough to make the graph correct. If it's a problem from the book that you need to graph by hand, make sure you use graph paper for any of the problems that come from the book. Okay, so for the book problems, make sure you use graph paper, and in that case, you would graph all 5 points. So one thing I want you to notice is that this is the graph of the parabola shifted up 2. There's also a vertical stretch, but what I need you to remember is that this plus 2 right here is going to shift the graph up 2. So the second question on MyOpenMath reviews the shifting. If you add, you're going to go up. If you subtract, the graph goes down. And if the shift is left or right, then you're going to see the shift inside the square. You're going to see a parenthesis with it squared. In addition to shifts, up and down, right and left, you also need to pay attention to whether the parabola is going up or if it's going down. Okay? This is how you tell. If the value right here is positive, then you have a happy parabola. See, this is a happy, smiley face parabola. In the event that you have something like this, if you have negative 2x squared, the negative right here means that you have a sad parabola. So the parabola looks like that, okay? So when you're looking at a graph and you need to figure out, like in question 4 on MyOpenMath, you have to match equations to graphs. One of the first ways to classify parabolas with their graphs is to look at whether it's an upward-facing parabola or a downward-facing parabola. Upward-facing parabolas always have a positive leading coefficient, positive, and downward-facing parabolas always have the negative, okay? So a negative leading coefficient makes it a sad parabola, and a positive one makes it a happy parabola. So now we get into some new territory here, starting with question 3. We're going to look at more of an analysis side of the graph. So what I want to do is to teach you how to find the vertex, how to find the x-intercepts, and how to find the y-intercept. So let's start with the vertex. To find the vertex of a parabola, there are 2 different ways to find the vertex. The first way is to use negative b over 2a. Okay, this is the vertex of a parabola formula. So the vertex formula, and you can have this in your page of notes for the test. Negative b over 2a is the x-coordinate. And then to get the y-coordinate, all you do is you plug that value back into the function. So really, the only part of the formula you need to pay attention to is how do you find the x-coordinate of the vertex. So what we want to do is identify a, b, and c. Remember that the form is ax squared plus bx plus c. So we can tell here that 9 is the a value. The b value is actually 0. So this negative 1 actually corresponds to c. I could have written it like this. Right? So a is 9. The b value is 0 because you have a 0x here. You do not have an x term. Anytime your x term is missing, that means you have a b value of 0. And then you have a c that's negative 1. So since the numerator here is negative b, anytime your b value is 0, that means you're going to have a vertex at 0. So that's a handy thing to notice. In question number 1, we saw that the vertex was at 0, 2. The reason was because we had a b value that was 0 as well. So once you figure out negative b over 2a, in this case, negative b over 2a would be negative 0 over 2 times 9, which is the same thing as 0, right? So you're going to then plug 0 back into the function, and when you plug 0 in, all you are left with is your negative 1. So this parabola is shifted down 1. And once you get a hang of parabolas, you can see that you don't even need to have the formula. If your b value is missing, you're automatically going to have an x value of 0, and the y value of your vertex is going to match c. Okay, so that leads me to how to find the x and y intercepts. Let's start with the y-intercept. This is a special case again. Anytime b is 0, this is a special case. It's an easier case. The vertex is the same thing as your y-intercept. So the vertex and the y-intercept will always be the same when b is equal to 0. So when b is equal to 0, your vertex and your y-intercept are the same point. What about the x-intercepts? So I said at the beginning of the course that if you ever need to find x and y-intercepts, you can use the same method. You get a table like this. You plug in 0 for x and 0 for y. This is the table that you use, the table for finding intercepts. We've already plugged in 0 for x, and we ended up with negative 1 for y. And now you can plug in 0 for y and figure out what the x value is. If you plug in 0 for y, your equation becomes 0 equals 9x squared minus 1. And we solve this equation using the square root property. So you want to have your perfect square on one side by itself. You can divide by 9, or you can just go ahead and take the square root here. 9x squared is a perfect square. So if you want to take the square root of both sides at this point, you are welcome to do so. But traditionally, I've taught you to get the variable squared by itself. So now we divide both sides by 9. The variable squared is by itself. Take the square root of both sides. Don't forget the plus or minus. That's very important. The square root of 1 over 9 is 1 over 3. Sorry, the plus or minus should go on the other side. Let me fix that. It's not wrong to put it there. It's just not very helpful to put it there. Okay, so we have the plus or minus 1/3 is equal to x. If you had done it this way over here, and if you had taken the square root of both sides, you would have ended up with plus or minus 1 is equal to 3x, and then when you divide both sides by 3, you end up here. So you could go either way, just because 9x squared happens to be a perfect square. Okay, so back up here, we're going to put the plus or minus 1/3 here. So what does that mean? That means I have two x-intercepts. One of the x-intercepts is at negative 1/3, 0, and the other one is at positive 1/3, 0. So there you go. So for question number 5 on my open math, you're to sketch a graph of f of x is equal to negative x squared plus 4, but you don't start with a table. So how do you graph this? Well, first you want to make the observation that because we have a negative leading coefficient, this is a sad parabola, so it's going to be a downward facing parabola, and it is shifted up 4. And you can use the observation that because the b value is 0, my vertex is at 0, 4. This is also the y-intercept. Okay, and then to find the x-intercept, remember you're just going to replace y with 0. Let's do that in black. Take the square root of both sides. So what that means is that we have x-intercepts at -2, 0 and at +2, 0. So this would be sufficient for graphing. On MyOpenMath, you just need to have 2 points. You need to have the vertex and one other point. So when you go to graph, you can simply put the vertex at 0, 4. And then pick the point 2, 0 or -2, 0. It will automatically now draw the curve for you by just having those 2 points right there. MyOpenMath will draw the curve correctly for you. So that's how you do a sketch. To do a sketch, what you want to do is focus on getting the vertex and then getting any intercepts. As it turns out, the vertex here is the same thing as the y-intercept. That happens anytime your b value is 0, which is what we have in this case. So I've already mentioned symmetry. Symmetry is when you can fold something in half. Well, this is one type of symmetry. There's rotational symmetry and line symmetry. But the type of symmetry that we're thinking of here with the parabola is line symmetry. It's where you fold the parabola in half and it's equal, okay? So you can see that you could fold the parabola in half right here along this green line right here. This is where you have symmetry. You have symmetry to the right and to the left. You could fold this parabola in half and it would be equal on both sides, okay? This is what is called the axis of symmetry. The axis of symmetry is going to be a vertical line, and that vertical line will always pass through the vertex, okay? So the axis of symmetry passes through, okay, that does not look organized. That looks like axis of passes symmetry through. Let me try that again. The axis of symmetry passes through the vertex. Okay, it always passes through the vertex. The equation of the axis of symmetry, since it's a vertical line, is going to start with x. Remember that when you have a vertical line always has the equation x equals some number. Okay, that's the generic form for a vertical line. So in this case, since all of the x values along this line are 0, and also because the coordinate here for the vertex is 0, the equation for this axis of symmetry is x equals 0. Okay, so this leads me to the next question. For question number 6 on MyOpenMath, you need to answer 3 questions. You need to say, what is the vertex? So this point right here is at 5, 3. So we say that the vertex is the point 5, 3. Use parentheses like this. The next thing you need to say is what is the axis of symmetry. Remember that the axis of symmetry is a vertical line that goes through the the vertex of the parabola. So the equation would be x equals 5. And then lastly, you just need to determine whether the parabola opens upward or downward. You can see that this is an upward facing parabola. So there you go. So what we're doing is through each question, we're trying to explore a little bit more about the graphs so that you have more of a comprehensive understanding of the graphs of a parabola. So you might want to say that we can classify parabolas into 3 groups. One way to classify parabolas are all the parabolas that look like this. This is the type that we've already graphed. What we have is a b value that's missing. So this parabola is just going to shift up or down. It's not shifting side to side. The vertex is the same as the y-intercept. So the next type of parabola involves a horizontal shift. That horizontal shift might also be accompanied by a vertical shift or not. Okay, so you could either see it with or without. So this would be without the vertical shift, and this is with the vertical shift. And so we're going to see horizontal and vertical shifts here. And then the last type that we're going to see is written like this. In most books, this version is called vertex form. Now, I like the book that we have. I picked it out myself, but no book is perfect. And one thing I do have about this book is this book does not call it vertex form. This book calls this standard form. Okay, so you just want to pay attention to the fact that this book calls this version standard form, whereas in other books it might be called vertex form. And in other books we usually call this one standard form. But in any case, just stick with the vocabulary of this book. It's not important so much as to what the name of the form is. Okay, what's important is that you know how to interpret the form. So what we're going to do is we're going to start by looking at how to interpret this form. The reason it's called vertex form in other books is because you can readily determine the vertex just by looking at it. The vertex of this form is h, k. Alright, so for example, if you had the equation, the function f of x is equal to 2x minus 3 squared plus 7, we would say that the vertex is at 3, 7. Okay? This negative right here is actually part of the form. So you don't pay attention to the negative. You just include this 3. Another way to think about it is that when we studied horizontal and vertical shifts, we saw that a horizontal shift was counterintuitive, and this minus 3 actually makes the parabola shift to the right 3, and then this plus 7 is up 7. Okay? Compare that to this other example. The fact that this is a negative 4 has no impact. Maybe I should just keep it as a positive 2. So the horizontal and vertical shifts are not impacted by this number outside. This number outside determines whether you have a upward facing or a downward facing parabola, right? So because this is a positive 2, that would make this a happy parabola, and because this is a negative 4, it would make it a sad parabola. but the number here does not impact the shifting at all. The shifting just comes from the number inside the squared and the number outside. So here we have a vertex. Since this is shifted to the left one, the vertex is at -1, and then this is a shift down 6, -6, okay? So basically just take the opposite of what you see here. If you see a -3, your vertex will be at +3. If you see a +1, your vertex is at -1. And then for the y-coordinate of the vertex, the y-coordinate of the vertex is simply going to match exactly what you see there for the k value. That k value that we had here and here is going to function in the same way. This is going to shift up or down. Same way here, up or down. So the +7 means that we shift up 7. The -6 means we shift down 6. So the vertex follows. So this form is really handy because you can immediately identify the vertex just like that. Okay, so for question number 9 from MyOpenMath, what we need to do is find the vertex and the intercepts. So let's start with the vertex. This is already written in vertex form, which is what the book calls standard form. You can see here that we have a shift to the right, 15, and we have a shift up 9. So that means that our vertex is at 15, 9. And when you're matching graphs in question 7 and question 8, the key is to identify the vertex, find the graph that has a vertex at that same point, and then check to make sure it's a similar upward or downward facing parabola. Okay, so the vertex is really easy to identify when you have a graph that's in vertex form, or as the book calls it, standard form. What about the intercepts? Remember, to find the intercepts, you make an XY table, you plug in 0 for X, and then you plug in 0 for Y. Okay, so here we're going to plug in 0 for X for starters. -15 squared is 225. 225 times 3, oh goodness, -675 plus 9 is -666. Right. It's a good thing we're not going to graph this one. Okay, so that would be the y-intercept. So the y-intercept then is at 0, -666. Next, for the x-intercept, we replace y with 0. So we replace f of x with 0. Hold on, I need to tell my child to stop talking behind the door. Okay, so what we've done here is we've replaced f of x, which stands for y. Replace y with 0. And now to solve this, we're going to use the square root property. So what we need to do is get this perfect square by itself. So I'm going to go ahead and move this over to the left-hand side. Then I divide both sides by 3. And then you need to take the square root of both sides. So now x minus 15 is equal to plus or minus root 3. So x is equal to positive 15 plus or minus root 3. So these x-intercepts are not at integers. Again, a good reason we are not graphing this. We're just analyzing it. So then for our x-intercepts, we would say that our x-intercepts are at 15 minus root 3, comma 0, and 15 plus root 3, comma 0. Okay, ready for the next one? Okay, so now I'm going to walk through example 5 from the book. This is from page 717. You have self-check 5 to do in your written homework. So we want to graph this function. First, we want to find the vertex. The vertex is the point 3, negative 4. So once you've identified the vertex, then you need to make an XY table. And you want your vertex to be the middle point. So I'm going to have 2 points to the left of the vertex and 2 points to the right of the vertex. You always need to graph 5 points, including the vertex. So to the left of 3 on the number line, to the left of 3 we have 2 and 1. And to the right of 3 on the number line we have 4 and 5. So we should see symmetry here because the vertex is always going to give us symmetry. So when you plug these values in, these should be symmetrical to these. That's a good way to check to make sure that you plugged in the numbers correctly and got the correct values. So if you plug in 4 here, 4 minus 3 is 1, 1 squared is 1, times 2 is 2, minus 4 is negative 2. Same thing if you plug in a positive 2. Plug in 5. 5 minus 3 is 2. 2 squared is 4. Times 2 is 8. 8 minus 4 is 4. So we graph. Use graph paper. When you're graphing this problem, this is a book problem, so use graph paper. So we graph all 5 points. 1, 4, 2, negative 2, 3, negative 4, 4, negative 2, and 5, 4. Connect the dots. Notice the x-intercepts are actually between 4 and 5 here and between 1 and 2 here. Make sure you do not go through 1 or 2 or 4 or 5. It's going to pass between. Next, we need to include the axis of symmetry. When we draw the axis of symmetry, the traditional way to draw it is as a dotted line because technically it's not part of the graph. The axis of symmetry is just an axis that shows where we have symmetry. It's not actually part of the graph. So use a dotted line, and the equation would be x equals 3. Remember, this x value will match the vertex. So that's how you're going to graph self-check 5. Okay, so now we're going to be doing the third type of parabola. The third type of parabola is in this form right here. In order to do this type of parabola, we need to have the vertex formula in front of us or memorized. In question 13 from MyOpenMath, the first question is, does the graph of the resulting parabola open up or down? Because this is a positive leading coefficient, a positive 2, this would be an upward parabola, right? Because we have a positive number here. So that was the easy question. Now we need to figure out what the vertex is for part B. To figure out the vertex, we need to identify A, B, and C. A is 2, B is negative 4, C is 10. So the vertex formula has us take negative b over 2a. Negative b over 2a would be negative 4 over 2 times 2. That's a positive 4 divided by a positive 4, which is 1. Now that is the x-coordinate of the vertex, right? So this negative b over 2a gives us the x-coordinate of the vertex. To figure out the y-coordinate of the vertex, we take the 1 and we plug it back into the function. So f of 1 is going to be 2 times 1 squared minus 4 times 1 plus 10. So that would be 2 minus 4 plus 10, which is 8. So that means that the vertex is at 1, 8. So when you have a parabola that's written in vertex form, or standard form as the book calls it, you can get the vertex like that without doing any work. You can just glance at the equation and see the vertex. But when you have a parabola written in this form, you have to do some work. You have to use the vertex formula to come up with the vertex. But the good news is, when you have a parabola in this form, the c value is your y-intercept. So the y-intercept will always be your c value. So you can figure that out really quickly. The y-intercept, you don't even have to show any work for this. You just look at your c value, it's 10. So the y-intercept is 0, 10. So that's all you need to do for question number 13. Okay, so for question number 15 in my open math, we have 4 questions to answer. First x-intercepts, then y-intercept, then vertex, then line of symmetry. So let's start with x-intercepts. Remember, to find the intercepts, we use this table right here. Plug in 0 for x, you get your y-intercept. Plug in 0 for y, you get your x-intercepts. So to get the x-intercepts, we're going to replace f of x with 0. And we have to solve this equation. This equation is not written in such a way that we can readily solve it by using the square root property, right? So if we don't have it already written in a way that we can write it using the square root property, then we need to consider 3 options. Can this equation be factored? If not, do we want to use completing the square, or do we want to use the quadratic formula? So if you do want to factor, you need to have a positive leading coefficient. So what I'm going to do is I'm going to multiply both sides by -1 to get rid of this -1 right here. Of course, 0 times -1 is still 0. Then I have x squared plus 4x minus 12. So I multiplied, or divided, it doesn't matter, both sides by -1. Now you can check. Are there factors of 12 that differ by 4? Yes, 6 and 2. So there's the factorization. So x is equal to 2, or x is equal to -6. So what that means is that you actually have 2 x-intercepts. You have 2, 0 and 6, 0. These are whole number, so you don't have to do any rounding, no approximation needed. You did not have to use factoring. If you wanted to, you could have used the quadratic formula, and the quadratic formula would have simplified to the same thing. My preference is to always factor if I can. Factoring, I think, is easier and more efficient than using the quadratic formula, but it's a personal choice, so you can choose whatever method you want. Once you have your x-intercepts, then we also want to get the y-intercept. That's a 6, not a b. To get the y-intercept, remember though that the y-intercept, you don't have to have any work. when it's written in this form, the C value is always going to be your y-intercept. So your y-intercept is 0, 12. You can also get this, of course, by plugging in 0 for x. We would have 0 minus 0 plus 12, which is still 12. And then next we need to find the vertex. So to find the vertex, we need to do negative b over 2a. So that would be a negative over negative 4 times 2 over negative 1. I'm using this original one right here. So negative b over 2a in this case gives me a negative 2. Okay, this is where I realized I made a mistake. I cannot have negative 2 be halfway between 2 and 6. You may have already caught this mistake. Good for you. This negative is supposed to be here. That's a negative. That's a negative. I caught that mistake because if the x-intercepts really had been 2, 0 and 6, 0, then I would have expected the axis of symmetry to be halfway in between 2 and 6. So the vertex would have had to have been at positive 4. But here now I have a vertex at negative 2. That means I made a mistake up here. That's how I went back and saw that, oh yeah, that was supposed to be a negative number. So 2 and negative 6 are 8 apart from each other on the number line, right? And halfway between 2 and negative 6 on the number line is negative 2. So now we're correct. So that's the x-coordinate. When you plug in negative 2, what you end up with is negative 2 squared minus 4 times negative 2 plus 12. Sorry, I got that crunched there. That is going to be a negative 2 squared is positive 4 with a negative out front. That's a negative 4 plus 8 plus 12, which is 16. So that means that my vertex is at negative 2, 16. Okay, and then I need to have my axis of symmetry. The axis of symmetry is going to have the same x value as the vertex. It's going to be a vertical line, so we need to have x equals negative 2. So the axis of symmetry is written as an equation, an x equals equation. The x-intercepts are written as coordinates, 2, 0, negative 6, 0. The y-intercept is also written as coordinates 0, 12. So that's question number 15. Okay, we have 5 problems left. I realize this is a long lecture. Remember that this is the big culmination lecture for the year. So it's long for a reason. Okay, so f of negative 5. This is question number 16 from my open math. It's a 4-part question. F of negative 5 is just to show you can evaluate at a given x value. So we have negative 5 squared plus 10 times negative 5 plus 13. So this is going to be, that's going to be a negative 25 and a negative 50, which is negative 75. Negative 75 plus 13 is negative 62. Okay, for the vertex, remember that the vertex, you're going to use negative b over 2a. So we're going to have a negative 10 over 2 times negative 1, which is a positive 5. So the vertex is at positive 5. And then we're going to plug that in. F of 5 is negative 5 squared plus 10 times 5 plus 13. So this is 50 minus 25, which is 25, plus 13 is 38. So the vertex is at 5 38 for the y-intercept. Just look at the c value. The c value is 13. Now this only works, remember, when you have ax squared plus bx plus c. C is not the same as k. The k that we were using in vertex form, or what the book calls standard form, is going to be your vertical shift. This is not the same thing as a vertical shift. This is the y-intercept. Lastly, the question says for part D, find the two values of x that make f of x equal to 0. This is a fancy way of saying find the x-intercepts, okay? Because the x-intercepts are the values that make f of x equal 0. So we plug in 0 for f of x. So 0 is equal to negative x squared plus 10x plus 13. This will not factor. So we either have to use completing the square or quadratic formula. I think in this case I'll go ahead and just use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That becomes negative 10 plus or minus the square root of 100 minus 52, right? 4 times 13 is 52. So that would be 48 over negative 2. So that becomes negative 10 plus or minus 4 root 3 over negative 2. If you need to show some work off to the side, the square root of 48 is the same thing as the square root of the square root of 16 times 3, which is 4 root 3. So you can either just simplify that in your head, or if you do want to show some work, just show it off to the side as scratch work. Okay, so now what I need to do is I need to factor out a negative 2 from the numerator so that I can cancel with the denominator. Negative 10 divided by negative 2 is positive 5. When you factor out a positive or a negative from a plus or minus, it's still plus or minus. And then 4 becomes 2 root 3. Think about it this way. If you factor out a negative 2 from a plus, it becomes a minus. If you factor out a negative 2 from a minus, it becomes a plus. So plus or minus becomes minus or plus, which is the same thing as plus or minus. So now the negative 2's are going to cancel. Remember, don't ever cross through your work. We end up with 5 plus or minus 2 root 3. So for this problem on my Open Math, it says to list the values separated by commas. So that means that you are actually not going to write them as x-intercepts. You're just writing them as x values. They are the x-intercepts, whether they are the x-coordinates of the x-intercepts. So you're going to have x is equal to 5 minus 2 root 3, and then the other one is 5 plus 2 root 3. So that would be separated by a comma. Okay, so I've decided I'm just going to do 3 more problems. number 70. Okay, so I have f of x is equal to 3x squared minus 12x plus 12. Sorry, there you go. Determine the coordinates of the vertex, determine the x and y intercepts, and then graph. Okay, so we need to find the vertex, the x-intercepts, the y-intercept, and then graph. So let's start with the vertex. The vertex is going to be at negative b over 2a. So negative b over 2a is negative 12 over 2 times 3. So positive 12 divided by 6 is 2. And f of 2 is 3 times 2 squared minus 12 times 2 plus 12, which is going to be 12 plus 12 is 24 minus 24 is 0. So as it turns out, the vertex is actually the point 2, 0. In this case, the vertex happens to also be one of the x-intercepts, but that doesn't often happen. Okay, so once you find your vertex, then the next question is how to find the x and y intercepts. Remember that we use this table. Plug in 0 for x, plug in 0 for y. Since we have a c value of 12, that is your y-intercept. Okay, so that means that the y-intercept is 0, 12. Use parentheses. And then to figure out the other intercepts, the x-intercepts, we plug in 0 for y. So up here, we rewrite this as 0 is equal to 3x squared minus 12x plus 12. We have a GCF of 3, so if you want, you can divide both sides by 3, and this will make it a little easier. So that gives us 0 is equal to x squared minus 4x plus 4. And then we want to ask, are there two factors of 4 that add up to 4? Yes, 2 and 2. This actually ends up being a perfect square trinomial. So then, whether you use the square root property or the zero factor property, you get x is equal to 2. So in this case, there is actually only one x-intercept. Why is that? Well, when you have a graph that bounces off the x-axis, as you do in this case, when a graph bounces off the x-axis, when there's only one x-intercept, it's because the vertex is the x-intercept. So whenever you happen to have a vertex that is also an x-intercept, it will be the only x-intercept. So that's a unique situation where we only have one x-intercept. So the x-intercept in this case is 2, 0. Okay, so now that we have the vertex and the y-intercept, I'm going to go ahead and write that information up here. The vertex is at 2, 0. The y-intercept is at 0, 12. And the x-intercept is at 2, 0. I'm writing that all up here at the top because I need to erase and graph. Now, when you do number 69 in your homework, you don't have this scenario. You'll end up with two x-intercepts. The vertex is not the x-intercept. It's nice in that situation because then you already have 4 points. I only have 2 points here. So to graph, I need 5 points. When you graph number 69, after finding the vertex, the y-intercept, and the x-intercepts, you'll already have 4 points, and you can find the 5th point through symmetry. Otherwise, if you have fewer points, then you need to make an xy table. The middle point is always going to be your vertex. And then I want to go to the left of 2 and to the right of 2 on the number line. To the left of 2 is 1, 0. To the right of 2 is 3, 4. I already know that this point is 0, 12. So by symmetry, this point over here is also going to be 12. So this is 4, 12. And now I can just plug in 1 or 3. F of 1 is 3 times 1 squared minus 12 times 1 plus 12, which is 3. So both of these will be 3 by symmetry. So I will have a point at 0, 12, another one at 4, 12, 1, 3, and 3, 3, and then 2, 0. So that graph includes 5 points, and I have shown algebraically how I've come up with the answers. So when you do number 69, you need to show me, in order to get full credit, you need to show me the algebra of finding the x-intercepts. You do not need to show any work for the y-intercept because c is equal to the y-intercept, but you do need to show me the algebra of finding the x-intercepts. You also need to show using the vertex formula to find the vertex. So that's the work I'm going to expect you to show for number 69 before you graph it. And when you graph, use graph paper. Okay, so I'm going to end the lecture today by doing 2 word problems. Starting with page 722, example 10. A glassworks that makes lead crystal vases has daily production costs given by the function C of x. Okay, so we know that C stands for cost. This would be in dollars. C of x is equal to 0.2x squared minus 10x plus 650, where x is the number of vases. Notice they have defined the variables for us. So C is cost and X is the number of vases. How many vases should be produced to minimize the per day costs? All right, so let's think about this. This is a quadratic function. The graph of a quadratic function is a parabola. It's going to look something like that, right? We know it's a happy parabola, an upward facing parabola, because the leading coefficient is positive. So where is the minimum point of the parabola? When you have an upward facing parabola, the minimum point is always going to be the vertex. So to figure out the minimum that should be produced, the minimum per day cost, you need to figure out the x coordinate and the y coordinate of the vertex, okay? So we're going to figure out what the vertex is and then translate or think about the meaning of the vertex, okay? So negative b over 2a, negative 10 over 2 times 0.2, that's going to be a positive 10 over 0.4. Just use your calculator for that. It's probably going to be like 25. Yes, 25. The way I figured out it was 25 is 0.4 is the same as 2/5. If you divide 10 by 2 over 5, it's the same as multiplying 10 by 5 over 2. So you get 50 divided by 2, which is 25. Okay, so that is the x-coordinate of the vertex. Now to get the y-coordinate, we plug in 25. Plug this in on the calculator. Alright, so that's 525. Okay, so what that means is that we have a vertex that is at 25, 525. Now remember this, that the x represents number of vases, and c, which is your y, is cost, and that is in dollars. So let's look at the question. How many vases should be produced to minimize the per day cost? 25 vases should be produced. And then what will the cost be? The cost will be $525. Okay? So when you do self-check 10, it's the exact same type of problem, just different numbers. So follow these same steps. Okay, last problem here. In your written homework, you need to do number 87. So I'm going to walk you through number 88. So both 87 and 88 have in common that you are dealing with projectiles. In 87, it's a firework. In 88, it's a ball. But both fireworks and balls are going to be projectiles, and they're going to follow a height formula that is a function of time. The height in 87 and 88 are both given to you, the height functions, and in both cases, the height is actually s. Now, while it may seem weird to have s for height, it's a common thing in parametric equations for s to be height, so it doesn't really matter what the variable is, remember that, okay? So in this case, they have chosen s for height because that's what's used in other contexts, like parametric equations. Okay, and then t is time. And time is in seconds when you have projectiles. And you will always see a negative 16t squared as long as we're dealing with feet per second gravity. Gravity is either in meters per second squared, which is 9.8 meters per second squared, or in the case of feet per second squared, the acceleration due to gravity is 32, and it's always half of the acceleration due to gravity for the leading coefficient, a negative 16 t squared, as long as you're on planet Earth. Negative 16 t squared plus 32t plus 48. FYI, the 32 tells you that you have an initial velocity of 32 feet per second when you throw this ball, and it is thrown from an initial height of 48 feet. Okay, you don't have to know that to do this problem. What you have to do is to find the maximum height of the ball and the time it takes to reach the maximum height. So this is a downward facing parabola. And when you have a downward facing parabola, the maximum is going to be the vertex, right? So the minimum is going to be the vertex, the maximum is going to be the vertex. Anytime you have a min or a max problem, a word problem with parabolas, that means you are looking for the vertex. So let's find the vertex. Negative b over 2a, negative 32 over 2 times negative 16. Aw, they gave you such nice numbers. 1. In number 87, they did write this formula out of order. You do need to rewrite the formula for number 87 in descending order so that you correctly identify A, B, and C. Or not, you could just rearrange it in your head and correctly identify A, B, and C. But pay attention to the fact that in number 87, it's not written in descending order. So you do need to be careful in identifying A, B, and C. Okay, so that's 1, and now plug 1 in. S of 1 is equal to negative 16 times 1 squared plus 32 times 1 plus 48, which is going to be 80 minus 16, which is 64. Right. Okay, so 1 comma 64 is your vertex. Let's interpret this. Remember that the x-coordinate or the t-coordinate is time in seconds, and the y-coordinate, or in this case the s-coordinate, is the height in feet. And this is the max height, okay? So you have a max height of 64 feet after 1 second. And that's all you have to do for number 88. Okay, so you made it through this very big lecture. Congratulations. Good job. And yeah, if you can master this lecture, you really have got a lot out of this class, okay? So pace yourself. Realize that this is a difficult and challenging lecture because you are synthesizing a whole lot of concepts together all into one. And be proud of yourself. It is a difficult mountain to climb, but a worthwhile mountain to climb. Okay, see you next time.